Welcome to Digital Toolbox. Today we're going to create a space frame from several different definitions. And the first definition we're going to use is the list item tutorial definition, where we create a faceted structure. And I'm going to delete these lines here. And then the next definition that you need to have is the evaluate surface tutorial definition. And you guys can watch that to get these buttons. And I'm just going to copy everything except for the lofted surface button and the pipe and the radius controllers, and none of these sliders. So I'm going to copy and then I'm going to paste this into the list item tutorial definition. And then the surface that we want to evaluate are the faces that we exploded from the subsurface. And then I'm just going to show these lines so you guys can see the normal vectors. And then I'm going to go to curve and grab the endpoint button to find the endpoint of these lines. I'm also going to change the slider to 24 instead of 48. And then what I'm going to do is I'm going to create my web members for the space frame from the endpoints and the listed points. So I'm going to copy and paste these lines, and I need 4 of them. And then I'm going to put A to the listed items. And then all of B's will go into the starting point of the normal vector lines. And this will create our web members. And then I'm going to unpreview these points. I'm also going to change the sliders for the U and V, the name to its respective name. So the top one would be U and the bottom one would be V. And I'm going to change this to 5 and 5 so it's easier to work with. And then I'm going to drag these sliders over here because I'm going to need them soon. The next thing we need to do is to create our framing for our web members. So to do that, I'm going to spline and grab the polyline button, and it's asking for vertices, so I'm going to connect these vertices to here. And then as you can see, it's not fully closed polyline, so to do that I'm going to right click on C and set boolean from false to true, and it'll give us a closed polyline. I'm also going to join these web members together so I have less geometry to worry about when I bake them. So I'm just going to hold down shift and join these together. I'm going to unpreview these lines. And now we need to create our top frame. And to do that, we need points from the endpoints. So I'm going to go to parameters and grab the point button. And grab a panel. You guys don't need to grab panels to see this, but it's nice to see how the points are formatted. So now as you can see that these points are not a list of numbers, as in is from 0, 1, 2, and 3, and so on. To get a list of numbers, we're going to right click on point and click on flatten. And what flatten does is now it gives us a list of points, as in from 0 to 24, which is 25 points. And now we need to create a sublist so we can create our polylines from our points. Since we only want lines coming from here and across and then restarting every 5 points, we need to create sublists. So we can go to logic, go to list, and click on sublist. And I'm going to reconnect that into the points because that's the list that we want to evaluate. And then I'm going to unpreview these. And then we need interval because that's what I is asking for, interval of indices to copy. So I'm going to go to scalar, go to interval, go to interval. I'm going to connect that to I. And to create a interval, as you know, if you watch the range versus series tutorial, we need series. So I'm going to grab 2 series, connect that to B and A, and then I'm going to grab a panel so you guys can see. And then U is going to go into the C values, since that's how many values that we want in the U direction. And then for the increment will be our V. And then our starting point for one of the series will be 4 or 5 points. or 4 points. So we need a logic expression, or expression from the logic. I'm gonna edit this to x minus 1, and v is going to go into x, and r is going to go into the bottom series to create our list here. So you can see here we have a subset of list from 0 to 4, 0 to 4 with 5 points in each subset. And this is how we're going to create our polyline. If we didn't do this and we connect the polylines to our points, it'll keep connecting, such as it goes from here all the way across and then connect to the next point. We just want lines going across like this, and that's why we create the subset list. And now if we connect that to the subset, we have our lines. So I'm going to bring this to the top. And now we need to create lines going the other direction using the same points. So that uses a list in logic, a list item. I'm going to connect that to the list that we want to evaluate. And then for I, we're going to use a series. Since the first point starts here is 0 and then goes to 1, 2, 3, 4, and then the next one will be 5, 6, 7, 8, 9, and then 10, and so on. So it goes from 0 to 5, and so on. So to do that, we're going to use a series again. Whoops, meant to grab a series, and we're going to put that to I. And once again, the value for C is going to be 5, and the end value will be the same values for V. And then the starting value is going to be different for each row. So I'm going to unpreview this so you guys can see that right now we have 5 points, and if we create a polyline, if I go to curve and grab another polyline from spline, we have one line going that direction. So we want to follow this trend so that each starting point starts differently. So it goes from 0, 1, 2, 3, 4. So to do that, we're just going to grab this another series. Go to sets and grab another series, and then I'm going to put that into the starting point. And then how many values going in the V direction is 1, 2, 3, 4, 5. So that's the V direction. We're going to put that into the value. So now we have polylines going across the other direction. And now you guys are practically done with your space frame. One more thing to add, if you guys want, is go to surface, go to primitive, and grab sphere, and grab a number slider, and put this into the radius of the sphere. And then the points on the sphere will be the points and the vertices. So you guys have nodes for your web members. And then I'm going to grab a receiver, and I'm going to put the receiver to all this. And then I'm going to go to surface and then go to freeform, and I'm going to pipe this. I'm also going to make the radius of the pipe a little bit smaller than the nodes, so the nodes are visible. And then I'm just going to connect the pipe to the receiver. And as the computer is cranking out the pipe, you guys will see the space frame. They take a really long time to do, so I don't actually connect the receiver into anywhere until I'm ready to pipe or to bake into Rhino. So that's how you create a space frame in Grasshopper using a subset list and an item callout using a nested series. Also using the previous definitions such as the evaluate surface and the item list definitions to create our space frame. And thanks for watching.